Hi and welcome. I'm trying to learn space science. Today, where does space begin? And after we've done it, we're going to do shoulder impingement training. Shoulder impingement is when the scapula is too much in front and we're training to make it further back. And if you participate in that after we've done here space science, that's at your own risk. Now, where does space begin? It's easy to think that space begins where Earth's atmosphere stops, but it's not that simple. Okay. Now at some point Earth's atmosphere stops, and it's not so simple that where just space begins. The air gets thinner and thinner the higher you go, and there's no hard line. After asking the question for years, most scientists now agree that space starts at the Kármán line. Okay, here's a little graphic. Let's go to the graphic before we go on. Now where is the Earth? There's South America, North America, Africa, Europe and Asia. And here is the Kármán line, see, by 100 kilometers. There by 21 kilometers, there are lower space. And below 152 kilometers, there can be some balloons. And now higher up, that seems to be some weather things? No, it can't be weather. Maybe some meteors. And here a bit higher, there seems to be this infrared, this type of light. And here higher, there are satellites. No, not satellites. Maybe spaceships, whatever. No, and here's the Kármán line, around 100 kilometers, so higher than planes. We're going to read on what it all means. So the Kármán, or Kármán, I can't really pronounce it. Kármán line. And this is a made-up line, so it's just invented. 100 kilometers above Earth's surface. Well, if it's good that they invented it and chose one, but they chose one so simple, with 100 kilometers. In most countries, you have to cross the Kármán line to become an astronaut. In the United States, astronauts can earn their wings by flying 80 kilometers above the surface. Okay, they say you can get an astronaut by getting over 100 kilometers over the Earth. Just the question at the time, because I wanted to make a joke about it. You can try to jump that high. But what would happen if someone would jump 100 kilometers high? What would it do to the Earth? So, like Newton's law, how much would the Earth push away if someone could actually just jump 100 kilometers high? And how deep would that make debris in the ground? Because you have to jump very hard to come just a meter up, or a little over a meter. And it seems almost, and it must get exponential. It seems to be completely irrational to jump that high. But just what would happen? Okay, now where does space begin? 100 kilometers above Earth's surface, as they're saying now. We're going to read it again because I didn't pay it for the attention. And in the United States, there were people saying you are an astronaut if you were 80 kilometers above the surface of the Earth. Now let's read it again. Where does space begin? It's easy to think that space begins where Earth's atmosphere stops. But it's not that simple. The air gets thinner and thinner the higher you go, and there's no hard line. So the air gets thinner, the air that you can breathe, we humans, and also the animals and plants. And where the planes are, there's already not so much. So at around 10 kilometers, there's not so much air. And then 20, 30, 50 kilometers, there's almost no air anymore. The air gets thinner and thinner the higher you go, and there's no hard line. After asking the question for years, most scientists now agree that space starts at the Kármán line. And this is a made-up line 100 kilometers above Earth's surface. So we can't say it exactly because it's not a fixed point. It's just the air gets thinner and thinner. The atmosphere just slowly ends. It's a fluent transition. So we don't really can say it, but we just said 100 kilometers. And most scientists have agreed, yes, let's say 100 kilometers. Let's just say 100 kilometers. The Kármán line, 100 kilometers. In most countries, you have to cross the Kármán line 100 kilometers above the Earth's surface to become an astronaut. In the United States, astronauts can earn their wings by flying 80 kilometers above the surface. Now, to the end, again, that thing here. And there's the Earth. And 100 kilometers above the Earth, so far over planes and balloons, whatever these are. Meteors, I think. There's the Kármán line, this made-up invented Kármán line. And if you are higher than that with a spaceship, then you are considered an astronaut. Okay, we're going to do a second part to that question where space begins, and then we're going to learn to try to make it as a presentation that I gonna make them a presentation in a separate video. Where I'm gonna tell other people that we can have, where you can watch my video, and I'm gonna explain to them shortly where the space starts at the carbon line, 100 kilometers above the Earth. It's basically what. But we're going to do a separate video of it. Now, if you were here for the current line, you can go directly to the next video where we're going to prepare and probably also do the little presentation. If you were here for a short impingement training, we're going to do it now, but if you participate, let's say on this. We are doing forward shoulder circles. Next, shoulder and front part. We are breathing, you can breathe whatever you want. We're doing shoulder circles. Leg arm back, up, and front, and down. And again back, up, and front, and down. And now backwards and front, up, back, and down. And now, lift the arms up. And let them down again. All we're going to do is to observe what the scapulars are doing. If this exercise causes pain, then don't do it. So just bring the arms up, and maybe you notice that the shoulder impingement happens, then you probably should stop because of pain. Otherwise, you may notice that the scapulars are opening a bit up, and that there is enough room for the arms to open, then you don't have shoulder impingement. Basically, to have it simplified. And last time the arms up. And down. Now the outside, and something similar, just the arms in front, and observe what the scapulars are doing. The scapulars are going now back together, and now to the outside. Back together, and to the outside. And last time, and back together. And the next exercise, the world lifter. Good and stay the same. Long arms, strong fists, and bring the shoulders down together, not turn the arms to the inside. Shoulders down and together, arms to the inside. Now the arms to the outside, shoulders down, head together. Arms to the inside, shoulders down, head together. Now the arms back, shoulders down, together. And that was last time. Something similar, arms at the side, hip in the front, bring the arms in front, shoulders down, hands together. Now the arms back, shoulders up and a shot. Change again, arms in front, shoulders down, hands together. And change the last time, arms back, shoulders up, and a shot. And freeze. And now shrug. Lift the arms up. Shrug, shoulders up. And release it all down again. And again the arms up. Shoulders up. And all down. And again, arms up. Shoulders up. And down. And now, by Pretziker, arms together and to the outside. Just observe what the scapulars are doing. And this is already the last time. And now the sun diver. I'm going to use a sock, you can use whatever you want. And we're having a long arm. And we're letting it fall down. And we're wandering slowly. And on the other side, you're trying to catch it again. And we're just doing a bit stretching. The arm in front, shoulders back and down. Pull the arm in, half lift fingers, stretch, relax the arm. Go a bit back from the shoulder. No, the shoulder is back and down. Pull the arm in, half lift fingers, try to relax the arm and go a bit back with the shoulder. The other arm in front. Shoulder is back, hands down. Pull the arm in, have flat fingers. Try to relax the arm and go a bit back with the shoulder. And that was a short attention training. I thank you very much and until next time.